This is the audio booster project for Justin and Matt as a part of the Experimental Methods class, spring 2013 semester. Here is our overall circuit, just to get a general overview before we start explaining the minor details. We're hooked up to a V-in source of an iPod running through our amplifier circuit with a volume knob, and we're getting this output for it's actually a string track, and there is an example of some of the gain we were able to get on it from 0 to the max at the voltage rails when the op-amp is fully saturated. We will start our explanation with the voltage divider portion of the circuit, which just provides our supplies for our op-amp. We've got an 18 volt source. We've got in parallel, we've got this LED that will turn on simply when the voltage is applied. We've got 200k ohm resistors to divide the voltage into +9 and -9. We've got a couple stiffening capacitors which help stabilize the voltage, and then our reference or our floating ground here in the middle. And so coming over to the actual circuit, we've got an 18 volt supply there coming in across this LED, and there are our 200k ohm resistors that divide the voltage, and our two capacitors which stabilize the voltage and output the +9 on the red and the -9 on the black. And we've got the ground there in the center. For this circuit, we chose an audio grade quad op-amp, the TL074CN. We chose this particular op-amp because we needed the op-amp to have stereo application, and each left and right requires 2 op-amps to run through. A brief rundown of the pins. We've got the outputs here, up top here, and down here, and then as you can see briefly, we've got all the inverting, non-inverting, and our positive and negative sources here. And coming over to our circuit, just a brief look. Here is the quad op-amp, and you can see everything that is hooked up to it, and we will explain in further detail soon. Here is an overview, and we'll go through each component in specific detail of each of the schematics for left and right. Both are identical to each other, so I'm just going to go over this top one here and give you an explanation, and like I said, it matches this one. So here we have our V-in source, which is our iPod here, or any tone generator, and from here the source goes into the op-amp, which has a feedback resistor, which we used a 50 kilo ohm potentiometer for, and a 5 kilo ohm resistor back here running through the inverting pin, and we have a resistor from the non-inverting pin to ground. And what this does here is this allows us to adjust from 0 to 50k, which allows gains from 0 to roughly 10 times the voltage. And so it will come through here. At this point, it will have the gain that we adjusted the potentiometer to, which is this over this, but it will be a negative value as it has gone through the inverting pin. At this point, we'll run it across to another op-amp and also run through the inverting pin with a 2 kilo ohm here and a 2 kilo ohm here. Same setup. This side simply inverts the signal back to a positive voltage gain and does not amplify the signal any further. Now for an actual look at the physical circuit that we built. Following the same track as the description used when looking at the schematic on paper, we've got a voltage in source coming from the iPod, which comes into the breadboard, goes across a 5 ohm resistor, and into the inverting input. We then have a 50 kilo ohm potentiometer, which is our volume knob, which runs from the inverting input to the output pin. That output also runs across to the 2 kilo ohm resistor, across that and into the inverting pin for the next op amp. As we said, this has 4 op amps inside of it, and then a 2 kilo ohm runs from the inverting to the output of that, producing one side of our output.